Hello everyone, welcome back. So in today's lesson, what we're going to cover is direct linear variation, which kind of means something like this. So if something is directly related to something, we call this direct linear variation. So for example, if y is directly proportional or directly varies to x, then y is equal to kx. So you can kind of think of this as a straight line graph that doesn't have a y-intercept. Well, it does have a y-intercept, except the y-intercept is 0. Right? So an equation that looks like this means the line goes through the origin. K is a constant called the constant of proportionality or constant of variation. It is calculated by substituting any given coordinates into the equation y equals to kx. Okay, so I'll go through this in detail later. A direct linear relationship exists between x and y means this. If x increases, y also increases. If x decreases, y also decreases. With direct linear relationships, the y-intercept is always the origin, which means the x-intercept is also the origin. So let's go through an example. There's the mass of a type of steel is given for different volumes in the table below. So these are the different volumes and these are the different masses that correspond to the volumes. So you can think of each of these as representing 1 point for each, right? Okay. Now let's find the equation for m in terms of v. Okay, so what you do is this. So equation for m in terms of v. So what you want to start off with is this. M is equal to kv. Okay, so k is the constant of proportionality. And what we need to do is find what the k is. So how do we find the k? We can just substitute 1 point in. So we can substitute the first point. First point has an m of 23.4 and has a v of 3, right? So k times 3. Now, basically, solve for k. So to solve for k, you divide 3 to both sides, so you get what? I'm going to use a calculator. So 23.4 divided by 3 gives you 7.8. Okay, so k equals to 7.8. Now, once you find the value of k, you can substitute this value back into the equation. So therefore, m is equal to 7.8 v. Okay, so that's your answer. This is your equation that expresses the relationship between volume and mass. So you're basically coming up with your own formula. And if anything, this is actually even easier than the previous homework, because in the previous topic, we actually had to also find the y-intercept. But in here, y-intercept is just 0, so even easier. So that's the meaning of direct relationship. Okay. Find the mass of a piece of steel if it has a volume of 180 centimeters cubed. Okay, so basically to do this, you just substitute the value into the formula. So that they give you a volume of 180. So this is your volume. So substitute 180 into V. So mass is equal to 7.8 times the volume. And what does this give you? Okay, I'm going to use a calculator here again. 7.8, so you can use answer times by 180 gives you 1404. Make sure you write the units. So units here is what? Mass. Mass is in grams. So write grams. Alright. Next question. Convert 1 cubic meter to cubic centimeters. Okay, so this question isn't really related to this. This is just something that you just need to know. So we know that 1 meter cubed. 1 meter cubed is basically 1 meter times 1 meter times 1 meter, right? That's 1 meter cubed. Which equals to, now if you want to convert it to centimeters, you've got to convert each of the meters into centimeters, which is 100 centimeter times 100 centimeter times 100 centimeter. And what does this equal to? This equals to 1 million cubic centimeters. Okay, so that's how you do this. Now if you memorize the result, that's fine as well. You can just write down the answer straight away. If a piece of steel has a volume of 1 cubic meter, calculate its mass in kilograms. Okay, so basically we just use the formula again. Okay, so m is equal to 7.8 v, right? Now remember here, you got to be careful with units. Here the volume is in cubic centimeters, so that's why they ask you to convert 1 cubic meter to cubic centimeters. So if it has a volume of 1 cubic centimeters, that means it's got a volume of 1 million centimeter cubed. So this is equal to 7.8 times by 1 million, right? This is 7.8 million, right? So I'm just going to put the commas. Now, what unit is this in? Well, remember, the mass here is actually in grams, right? Because it says mass in grams. So this is in grams. Now, you have to convert this answer to kilograms because it asks you calculate its mass in kilograms. So just divide it by 1,000, you get 7,800 kilograms. And that should be your answer. So as you can see, these questions are actually pretty easy. Yes, the only tricky part is making sure that the units match. Okay, so be very careful with these units because the question can ask you to write your answer in kilograms, grams, tons, so on. So just be careful with that and make sure you know how to convert cubic meters to cubic centimeters. All right, let's take a look at another question. The amount of petrol used by a car traveling at a constant speed is directly proportional to the distance traveled. Okay, so what you can do is this. So as soon as you see the sentence, what you can do is just write down the formula. So amount of petrol, I can just say P is equal to directly proportional to the distance. So I can say K times the distance, right? A car uses 6 liters of petrol to travel 50 km. How much petrol will be used to travel 180 km at the same speed? Okay. So basically, just find the value of K. So petrol is 6. 6 is equal to K times what? The distance. Distance is 50. Right, so then what does K equal to? K equals to 6 over 50. So which, if you simplify it, equals to 3 over 25, right? Once you find the value of K, substitute the K back into here. So therefore, the formula, P is equal to 3 on 25 times D, right? And then the question says, how much petrol will be used to travel 180 km? So, in other words, sub 180 into here, and that will get you the answer. So then, P is equal to 3 on 25 multiplied by 180. So I guess what you can write here, you don't have to, you can write D is equal to 180. Therefore, P equals to this times 180, which equals to what? Okay, I can't do this in my head, so I'm going to use my calculator. So 3 on 25 multiplied by 180 equals to 18. And the answer, what unit is it? It's in liters. Okay. Now, this is how you can do this question through the method that I taught you today, but I'm just going to tell you another way that you can do this, which is actually a lot easier, okay? And it's called the cross method. So if a car uses 6 liters to travel 50 km, and the question asks you how many liters to travel 180 km, what you can do is this. Just draw a cross. And then what you do is do 6 times 180 divided by 50. Okay. So what you can just do is, so I mean, this is the quick way to do it. So, but it might not work with every question. So x equals to 6 times 180 divided by 50, right? And this will also give you 18 liters. So this is the quick way. So I guess in the future, if a question is worded like this, and if it doesn't ask you to find the equation, so find the equation with the constant of proportionality, then you can just use this method. It's much easier. All right, let's take a look at another question. The volume V liters of water in a tank as it is filled is proportional to the time taken. Okay, so V is proportional to T. So what that means is this. V is equal to KT, right? Find the constant of variation. Okay, so the constant of variation is basically finding the K. And do you know what K is equal to? K equals to V over T, right? And what this is basically the gradient of this graph, okay? Because think about it, V over T is what? V is the rise, T is the run. So it's just the gradient. So let's just pick a point which we can easily read off. So let's just pick that point, okay? That point looks pretty good. So we just have to find the rise. So what's the rise here? So which equals to, the rise is 320, right? 320 over run is 5, right? So what is this equal to? 64. Okay, so that's the constant of variation. So K equals to 64. What does the constant you found in part A represent? Okay, so now this question is similar to the questions that they asked yesterday about what does the gradient represent. So you can say the gradient, that's the rate that the volume goes up, right? So you can say the rate in which the volume increases per minute, right? And the reason I'm saying this is because the x-axis is minute and the y-axis is volume. So you can just say the gradient is the rate in which the volume increases per minute. So what that means is that after 1 minute, the volume will increase by 64 liters. Okay. So it's very important that you actually understand what the gradient represents, because these are the types of questions that students get confused because it's not familiar or it's not similar to the questions that they've done in the past. The questions they've done in the past are basically drawing straight lines, finding gradients, y-intercepts. But what they don't realize is the meaning behind the gradient. So make sure you understand this. And these questions generally have different answers, but the concept is always some kind of rate. Okay. Calculate the amount of water in the tank after 8 minutes. Okay, so for this one, you can either try to read it off, but I wouldn't recommend that because you're not actually sure how much it goes up. It's somewhere between 480 and 560, so that's something we know, but we don't know exactly. So what we can do is just substitute into the formula. So we know that K is equal to 64, right? And V is equal to what? 64 times T. So this is our formula that we worked out. The amount of water in the tank after 8 minutes, so T is equal to 8, right? So then V equals to 64 times 8. So this will give us the precise answer. So this is what? 48, 51, 512. And this unit is in liters. Right, so by doing this, we know the exact answer. Now, if you actually tried to use the 8, would you have known this is 512? Probably not, right? Okay. Calculate how long it takes to pump 960 liters of water into a tank. So for these questions, very standard. Just substitute the 960 into the original formula. So V in this case equals to 960, right? So we sub it in here. So 960 is equal to 64T. So T equals to, so 960 on 64 is equal to T. So if you type this onto your calculator, you can just 960 divided by 64. Okay, 15. Good. So it's got a nice number here. So then T equals to 15. Now, is this 15 the hours, 15 minutes? So let's just take a look. So I think the unit for time here is minutes. So then minutes. Right. So hopefully this is pretty straightforward, as it's basically trying, like, these kind of questions are basically trying to ask you, okay, so I give you the y value, find the x value. I give you the x value, find the y value. So basically just make sure you find the formula first, the equation. This is the most important part. And to find the equation, you got to find the gradient. So it's pretty easy. You don't even need to find the y-intercept because it always goes through the origin. Okay. So I think that's all for today. I think these questions should be quite straightforward. If anything, I think today's work should be easier than yesterday's because there's no y-intercept. I mean, there is a y-intercept, but it's at the origin. So just to summarize, what we learned today is basically how to find constant of proportionality, in other words, the gradient, and what direct linear variation is. Okay, so if I have a relationship that's something like this, y is equal to 2x plus 1, this is not a direct linear variation because it has a y-intercept of 1, and it does not go through the origin. It has to go through the origin in order for it to be a direct linear variation. So this is not direct. So, all right, so that's all for today. Thank you for listening.